Hey there, I'm Kai, your knowledgeable AI host. Welcome to Simplifying the Stack, where AI unpacks the cloud, containers, and code for people who make decisions, not deployments. Today, we're diving into the silicon heart of your infrastructure, Intel's new Xeon 6 processors, a generational leap in performance efficiency and scalability for the modern data center. Stick around, because by the end of this deep dive, you'll understand not just what Xeon 6 is, but why it matters for your business, your workloads, and, your TCO. So if you're making decisions about IT infrastructure, you know things move fast. The data center, it just never stands still, right?
Never. There's this constant demand for more performance, better efficiency, and honestly, just more flexibility to handle everything new. AI, microservices, you name it.
And that evolution, it really starts deep down, doesn't it, at the silicon level?
Yeah.
But it also affects how systems are actually built and put into racks.
Absolutely. Understanding those fundamental building blocks is, well, it's crucial if you want to make the right calls.
Exactly. And that's what we're getting into today. We've been digging through Intel's technical materials, looking at system stuff from HPE, some Q&As.
Yeah, lots of detailed info. It's all focused on this latest generation, the Intel Xeon 6 family.
Right, Xeon 6. And also how partners, like HPE in this case, are actually, bringing these new chips into the real world, into actual servers.
Yeah, our mission here is really to break down what makes Xeon 6 genuinely different. Not just specs, but why it matters for you listening, the business decision maker.
And how it's shaping the future, right?
Right.
Things like new modular hardware standards.
Exactly. We want to translate the tech talk into real business value.
Because that's the bottom line, isn't it? How does this translate? Can you actually get better performance where you need it most? Can you cut costs, boost efficiency for those big scale-out jobs?
Does it make your infrastructure more agile, protect your investment long-term?
That's the stuff people need to know. We're aiming for that knowledge shortcut today.
Okay, so let's unpack it. The really big idea with Intel Xeon 6, the most fundamental thing, is that you now have two different kinds of processor cores.
On the same platform.
On one single integrated platform. Yeah, that's a pretty significant shift from before.
So not just more cores, but different flavors of cores, designed for different things. You got the P cores, performance cores.
Right, and the E cores, the efficient cores.
And they live together. Same hardware foundation, same software view.
That's the key. Think of it like building a specialized team. The P cores, they're your heavy hitters, optimized for maximum performance per core.
Ah, so they tackle the really tough, compute-heavy problems.
Exactly, the complex stuff.
Like bringing in, specialized power tools for one really difficult job. They might use more juice, but they get that specific task done super fast.
That's a good analogy. And the E cores, they're optimized completely differently. It's all about performance per watt, efficiency, and density. Lots of them.
So they're built for handling just massive volumes of tasks all at once.
Precisely. Like, think of super efficient assembly line robots. Built for throughput, built for scale.
Okay, got it. Specialized problem solvers, the P cores. High volume masters, the E cores. So why is having both on the same platform such a big deal?
Flexibility. It gives you this incredible flexibility to match the right kind of compute to the right kind of workload across your whole data center.
Instead of one-size-fits-all approach?
Yeah. Instead of trying to make one general-purpose CPU handle everything, which always involves compromises, now you can deploy the optimal core type for the job. Raw speed needed, P-core. Massive parallel efficiency, E-core.
That lets you optimize at a much higher level then, strategically.
Totally. It's about optimizing your entire infrastructure strategy, not just isolated servers.
Makes sense. You need the right tool for the job. So let's dive a bit deeper. The P cores, those power tools, what are they specifically good at, according to the sources?
Okay, P cores are for your really demanding workloads. The compute-hungry stuff, we're talking intense AI tasks, both inference and training, especially on the bigger models where every bit of speed counts.
Right.
Also high-performance computing, HPC, relational databases, think MySQL, where query speed is king, and those core enterprise apps, ERP, CRM systems that need fast processing.
And is it just raw cloud speed, or do they have extra things built in, accelerators?
Oh, yeah, absolutely. Intel's integrated specialized engines right onto the P cores. Things like advanced matrix extensions, AMX, that really boost AI calculations.
Okay.
Supporting different data types like BF16, FP16 for faster model processing. There's also AVX 512 for vector processing, common in scientific computing databases.
And memory. Faster memory helps too, right?
Definitely. Support for things like MRDMs and CXL 2.0 for quicker data access, crucial when you're dealing with huge data sets. These accelerators basically offload work so the main core can focus.
Gotcha. So P-cores is power plus targeted acceleration for the big complex jobs. Now, what about the E-cores? What's their sweet spot?
E-cores are all about scale and efficiency. For workloads, you can break down into lots and lots of smaller parallel tasks. This is really the engine for the modern web and cloud.
So things like
Microservices, absolutely. Processing huge amounts of analytics data, content delivery networks, CDNs, network functions, like in 5G rollouts, storage solutions, HCI, VDI, web hosting, handling massive traffic loads, consumer apps, anything where you need density and efficiency at scale.
applications needing millions of transactions or requests per second, but efficiently.
Exactly that. And their key advantage is just incredible core density. We're seeing configs with up to, get this, 288 cores per socket.
288, wow, that's dense.
It's transformative. That density means you can get massive throughput in a much, much smaller physical footprint. Think grid-level compute power in just a few rack units. Saves space, power, cooling, it all adds up.
That density number really jumps out. It has direct implications for rack space and power budgets. Do E-cores also get those built-in accelerators?
They do, yes. Though some are maybe more tailored to the kind of high-volume scale-out tasks they handle. Things like Intel Quick Assist technology, QAT.
QAT, right, so crypto and compression.
Yeah, offloads that stuff. There's Dynamic Load Balancer, DLB for spreading network data efficiently. Data Streaming Accelerator, DSA, speeds up data movement inside the system.
Crucial for high throughput.
Totally. And even In-Memory Analytics Accelerator, IAA, for boosting database and analytics performance. Again, it's about taking those common repetitive tasks off the main CPU cores so they can just churn through more actual work.
Makes sense. Offloading grunt work to specialized hardware. Okay, but for the decision makers listening, the proof is in the pudding, right? What are the actual performance and efficiency numbers telling us?
Right. The sources give some pretty compelling benchmarks. For P-cores, on those demanding workloads, significant gains, like for GenAI using BF16, up to 2 times higher performance compared to the previous gen, the 5th gen Xeon.
Doubling GenAI performance, that's huge if you're deploying or scaling those kinds of services.
It absolutely changes the TCO and what's possible at scale. And compared to AMD EPYC, the sources show up to 3.7 times higher AI inferencing performance on certain models.
3.7 times.
For HPC, high-performance computing, it's up to 2x over 5th gen, and compared to servers that are, say, 5 years old, up to 6.1x improvement.
Wow.
Databases, too. MySQL OLTP performance, up to 2x versus 5th gen, and maybe 3.1x versus that older gear. Across the board for general compute tasks, they're saying up to 2x average performance lift against 5th gen.
So P-cores deliver serious speedups for compute-heavy stuff that directly impacts time to result, customer experience. Now what about the E-cores, where efficiency and density are the name of the game?
Yeah, the E-core efficiency story is really strong, especially for scale-out. Up to 1.6 times better performance per watt compared to 5th gen Xeon.
Better perf per watt, that's key.
And compared to AMD EPYC, the claim is up to 1.3 times better performance per watt. And looking at replacing older servers, maybe those 5-year-old workhorses, you could see up to 4.2 times higher overall performance in the same rack space.
And that's where the efficiency really hits the bottom line, isn't it? Lower costs, smaller footprint.
Exactly. That density and efficiency allows for, well, pretty radical consolidation. The sources talk about consolidating 3 full racks of those older 5-year-old servers down into just 1 rack using these new Xeon 6 E-cores.
3 racks into 1. Think about the floor space that frees up.
Yeah.
And the power and cooling.
Huge savings. The example given calculated it as saving nearly 1,540 megawatt hours and cutting over 650 metric tons of CO2 over 4 years. Just from that 3-to-1 consolidation, that's not pocket change, especially if you have sustainability targets.
Definitely not. Significant impact.
And even server to server, an E-core system might use up to 280 watts less power at typical loads compared to the previous gen. For specific workloads like media transcoding, Java throughput, CDN delivery, the perf per watt gains are really clear. It fundamentally changes the TCO picture.
Okay, so we've got these powerful specialized cores, big performance and efficiency gains. How does this tech actually land in your data center? That's where partners like HPE come in, right?
Exactly. HPE is among the first wave shipping systems built around Xeon 6. Specifically, their ProLiant DL320 and DL340 Gen 12 SP servers.
Gen 12 SP. And what's notable about these beyond the Xeon 6 inside?
Well, what's really innovative is how they're built. They're based on a newer industry standard called OCP DCMHS.
OCP DCMHS. Okay, acronym alert. Break that down for us. Data center modular hardware system.
Right. Think about a traditional server motherboard. It's usually this big, complex custom thing for that specific model from that specific vendor. Upgrading one part or servicing it often means the whole board, or it's just difficult.
Yeah, monolithic.
DCMHS changes that. It defines standard interfaces and physical shapes, form factors for key server components, like the system controller, networking cards.
So it's less like one giant circuit board and more like building blocks. Standardized, swappable pieces. Legos for servers.
The Lego analogy is pretty good, actually. Key bits like the system control module, the SCM that handles management, security, it becomes a standard module you can potentially swap out. These HPE servers use an OCP standard DC SCM, for instance. It's a fundamental shift.
And what are the real-world benefits of building servers like Legos, especially for, say, service providers or anyone managing lots of servers?
Well, for service providers who are the first target for these specific HPE models focused on general compute at scale, it means way more architectural flexibility. It's easier to adapt their infrastructure as needs change.
Makes sense.
They can right-size better, avoid overspending, improve TCO. Deployment gets simpler because you're using standard interoperable modules.
Okay, easier deployment, flexibility, better upfront TCO. What about down the road? Long-term benefits.
Big benefits there. Much better investment protection. If you need to upgrade just the networking or maybe swap out that SCM module later, it's much simpler than a whole motherboard swap.
Right. Easier servicing.
Easier servicing, potentially faster innovation cycles too, because vendors can focus on standard interfaces but innovate within the modules. It could lead to a broader ecosystem over time.
And even though these first HPE models target service providers, the sources suggest this modular DC MHS approach is where HPE is heading for their whole compute server line.
That seems to be the clear direction, yes. It's not just a niche thing. It's likely how many future servers will be constructed.
Interesting. And HPE still adds their own value on top of the standard.
Oh, absolutely. They integrate their leading security features, silicon root of trust, trusted supply chain checks, crucial in a modular setup. You still get that familiar ProLiant management experience and robustness. And flexibility in management, too. Use HPE's ILO, or if you prefer, load your own OpenBMC image onto that standard SCM module.
Okay, so we've covered the core architecture, the perf and efficiency boost, this move to modular systems. What about other critical factors? Security, sustainability.
Yeah, huge considerations, and they're major pillars for Xeon 6 and systems like HPE's. Security-wise, Intel's built a lot of hardware-based features right into the silicon. It's foundational protection.
Hardware-based security. Why is that better than just software?
It establishes a much stronger root of trust. Features like Intel TDX, trust domain extensions, that enables confidential computing. You can isolate VMs, their data, even from the cloud provider or hypervisor.
So your stuff is protected even if you don't fully trust the underlying platform operator.
Precisely. SGX, Software Guard Extensions, does something similar for applications. Vital in multi-tenant clouds or sensitive workload scenarios.
Okay, so better isolation. What else?
There's also CET, control flow enforcement technology, to guard against common software attack techniques. Hardware-based memory encryption, TME, protects data while it's being processed. And platform firmware resilience, PFR, helps ensure the boot code itself hasn't been compromised.
Lots of layers there.
Yeah, and combine that with things like Intel Trust Authority for remote attestation, verifying the platform is trustworthy, plus HPE's system-level security.
Yeah.
It builds a much more robust defense posture.
Trust built right into the hardware, foundational. And sustainability, we touched on it with the consolidation numbers.
Absolutely. The efficiency, especially from the E-cores, directly cuts power consumption. That means lower electricity bills, lower OpEx, which feeds right back into the TCO calculation.
And the environmental impact.
Lower carbon footprint. Helps meet those corporate sustainability goals. It's a clear line from silicon efficiency to cost savings and greener operations. A real win-win.
Definitely compelling. What about flexibility after deployment? Other value adds?
Well, the shared software stack across P-cores and E-cores helps a lot. It simplifies development, deployment, management. You're working in one consistent Intel environment.
Familiar tools and processes.
Right. And Intel also has this feature called Intel On Demand.
On demand, what's that about?
It's essentially a feature activation model. It lets you turn on certain CPU capabilities after the chip is made, maybe even after it's deployed in your rack.
Huh. Like pay as you grow for CPU features.
Kind of, yeah. Or maybe you only need a specific accelerator later on. It offers flexibility, potentially helps optimize procurement, align features with actual needs over time rather than guessing everything up front.
Interesting concept. More agility.
Exactly. And then there are integrated features like Intel VRC Virtual RAID on CPU. It lets you create software-defined RAID using the CPU itself, potentially simplifying storage setups, saving cost on dedicated RAID cards.
Right.
So all these things, the deep security, the sustainability benefits, the ecosystem consistency, features like on-demand, VROC, they all add value around the core compute power. It's about building infrastructure you can trust, that's efficient, and that can adapt.
Okay, let's bring it back home. For you, the listener, making those tough infrastructure decisions.
Yeah.
What's the really big takeaway here?
I think the key takeaway is that Xeon 6 isn't just an incremental step. It fundamentally changes the game by offering these two distinct core types, P cores for performance, E cores for efficiency on one unified platform.
It's about choice and optimization.
Exactly. It empowers you to precisely match compute resources to your actual workload needs rather than compromising. And that translates directly into, well, significant performance gains where needed, dramatic efficiency and TCO improvements, especially for scale out, and just unprecedented density.
And when you layer that chip innovation onto the shift towards modular systems like we see with HPE adopting DCMHS, you're really looking at a blueprint for future infrastructure. More flexible, easier to manage, more cost-effective over its lifespan, better investment protection.
Understanding these shifts is pretty vital if you're planning infrastructure that needs to handle today's demands and be ready for whatever comes next, whether that's more AI, more microservices, or something else entirely.
Yeah, this combination of specialized cores and modular open hardware, it feels like more than just an evolution.
It really feels like a reimagining of how we build and manage data centers.
Which leaves us with a final thought to chew on. If you have efficiency cores perfectly tuned for massive scale and performance cores built for the most intensive tasks like AI, are we moving past just measuring data centers by raw power, by total teraflops?
And moving towards what?
Towards a future where the real measure of infrastructure is its intelligence, its ability to dynamically, optimally place and run every single workload on the best-suited type of modular compute resource available.
It certainly suggests a future where infrastructure intelligence and workload optimization become just as important, maybe even more important, than the raw hardware specs alone.
Definitely something to think about as you chart your own data center's future. That's a wrap on today's deep dive on simplifying the stack. Until next time, I'm Kai, where AI meets IT, and together we simplify the stack.